Assalamu alaikum students, I hope you all are fine. Students, we are in unit 1, that is programming techniques. In today's lesson we'll talk about the algorithm, that what is algorithm and why we use algorithm. In the previous lessons we discussed the problem analysis, candid solution of the problem, and before that we discussed planning solution of the problem. Then we discussed candid solution of the problem, which is also called best solution of the problem, and further we discussed the factors on the basis of which we select the best solution out of the available possible solutions for solving any particular problem. So today's topic is regarding algorithms. First of all, an algorithm is a well-defined list of steps for solving a particular problem. Informally, an algorithm is any well-defined computational procedure that takes some value or set of values as input. Because it is not mandatory or necessary that an algorithm will always take a single value as an input. There may be an algorithm which requires multiple values as an input, and same is the case with the output, that it may produce some value or set of values as output. Maybe the result is a single value or multiple values as an output. So it's a well-defined computational procedure which may require single or multiple values as an input and produces a single or multiple values as an output. An algorithm is thus a sequence of computational steps that transform the input into the output. So that is even more simple, that it's a computational stepwise procedure which converts, which transforms the input into output. We can also view an algorithm as a tool for solving a well-specified computational problem. So here in this diagram it is shown that the algorithm requires an input. It takes an input, and then after processing the input in a stepwise manner, it is converted into a desired output by the algorithm. Now, role of algorithm in problem solving. Algorithm plays an important role in developing solution to a problem. For example, if we have a complex situation which requires a lot of information to be gathered and a lot of data to be processed, then of course a complex and big problem cannot be solved as a whole. It's not that easy. We have to divide such type of problems into predefined portions, and then we solve those portions independently to come up with a whole solution of the problem. That is called divide and conquer strategy. Then by dividing each activity of this information gathering and data processing into steps will make the problem solving an easy task. So we have to divide the complex situation or complex problem into concrete portions or steps to solve it in a stepwise manner, and it makes the whole process of devising the solution of any problem very easy. Divide and conquer, a very famous rule that makes the problem solving an easy task. Let's have an example. For instance, let me take an example of finding the average of 20 numbers. As we discussed earlier, that it is very important to understand the problem solving or the problem statement completely to solve the problem, because until and unless we don't understand the problem statement completely, we cannot figure out the solution of any problem. So here it's a very simple statement which describes a problem, and it says that we take an example of finding the average of 20 numbers. So here we can see that 20 numbers will be taken as an input, then we have to write the steps to find the average. So we must know that what is meant by average and how we can calculate the average, means the formula used for finding the average of 20 numbers. So we will divide the whole problem into different steps, and we will write those steps in a sequence to write an algorithm for solving this problem. If this process is defined in small discrete steps, then we can make the solution very easily. So the first step will be select any 20 numbers, that is the input. Second, we have to calculate the sum of those 20 numbers. So second step is add all the numbers. As we know that for finding the average, we must calculate the sum of the numbers, and then we will divide it by the number of elements or observations. Third, divide the result of step 2, that is the sum, by total number of observations, that is 20, because total number of elements in this example is 20, and then the average will be calculated. So this is how we used to divide a complex problem into different portions, and we solve it in a stepwise manner. Now, criteria for measuring efficiency of an algorithm. As we discussed earlier, that there may be several possible solutions to solve a single problem, which means that there may be several possible algorithms for solving any single problem, but we have to select, or we have to know the best algorithm for solving any particular problem. So there is a criteria for measuring the efficiency of an algorithm. Efficiency means the best algorithm. Efficiency means the algorithm which works more, or which produces output in limited resources, or which work efficiently, or which work in the best manner with limited resources. Such type of algorithm is called efficient algorithm. So for measuring the efficiency of an algorithm, there is a criteria. In computer science, efficiency is used to describe properties of an algorithm relating to how much of various types of resources it consumes. Yes, that is the main thing. We have to see that how many resources are required by the algorithm. Resources in terms of time means processing time, and resources in terms of memory means memory space that it occupies while its operation or while solving the problem. The two most frequently encountered and measurable metrics of an algorithm are: number 1, speed or running time. Speed means that how quickly it can perform the function, and how much running time it requires, the time it takes for an algorithm to complete. And the second thing is space. Here space means the memory used by the algorithm during its operation. Furthermore, its efficiency can be measured on the basis of the following factors. So apart from running time and speed and space, there are some other metrics also. First one, inputs needed. What kind of input is required for the algorithm, and how large the input is. Second, processing to be completed. How much time it will take to process the inputs and convert it into output. That is the second metric for checking the efficiency of an algorithm. Third one, decision to be taken. And fourth one is outputs to be provided, whether the output that it produces in each case is the correct one or not. So whether the output that it produces for different inputs which are provided to the algorithm are correct or not. So in the coming slides we will discuss these 4 factors one by one. First one, inputs needed. The amount of time an algorithm takes depends on how large is the input on which the algorithm must operate. So if an algorithm requires multiple inputs or large inputs or complex inputs, we can say that the algorithm is not efficient with respect to the inputs that it requires. For example, multiplying huge matrices takes longer than multiplying small ones, etc. An algorithm might take different amounts of time on inputs of the same size. Second, processing to be completed. The time required to complete the operation is a measure for efficiency of an algorithm. The process completion time is composed of cycle time, wait time and processing time. These are different 3 different timings while processing an operation or during the execution of any set of instructions. So overall the process completion time is composed of cycle time, wait time and processing time. Some other time we will talk about the cycle time, wait time and processing time, and we will differentiate these 3 different timings which are used while processing any set of instructions or while performing any operation. But overall here we have to know that the process completion time is actually composed of cycle time, wait time and processing time. When these 3 different timings are combined together, so it makes up the overall process completion time. So if an algorithm's process completion time is longer, so it means that the algorithm is not efficient with respect to the completion of process, or with respect to the time it takes to complete a process. Third one, decision to be taken. Problem solving and decision making are important skills to improve the efficiency of an algorithm and get optimal results. So while decision making or while evaluating the logical instructions or making logical decisions, the algorithm must be efficient with respect to making decisions. And the fourth one, which is the last metric for efficiency of an algorithm, that is output to be provided. An algorithm is said to be correct if for every input instance it ends with the correct output, because we may provide different inputs each time when we execute the algorithm for solving any particular problem. It's not necessary that we will always provide same inputs to the algorithm. So we have to check the algorithm by providing different inputs to see that whether the output produced by the algorithm in each case is a correct output or not. That is called the efficiency of an algorithm with respect to the output that it provides. An incorrect algorithm might not end at all on some input instances, or it might end with an output other than the desired one. Maybe some algorithms will provide incorrect results for different inputs. So the algorithmic solution that provides correct desired output will be considered as the best solution for the problem to be solved. So if an algorithm satisfies all these different criteria, so it means that the algorithm is the most efficient one and the best algorithm for solving any particular problem. Okay students, that's it for today. If you have any question, you can ask me in the comments, and don't forget to subscribe my channel Computer Tuition Academy. Thanks a lot, take care, Allah Hafiz.